Hi everyone, in this video we're going to look at a hypothesis test for a sample mean, for a single mean. So, if we go to week 15, and in week 15 if you open up the file again, that's the modules 28 and 29, we're going to take a look at an example, and when we do that example you're going to want to have this hypothesis test file open. So, let's take a look at this example. So this example is located on page 21, and it talks about the mean life of batteries. So the story goes that this company sells walkie-talkie radios to construction crews. The batteries for these radios last for an average of 55 hours. So this number is pretty important because that's how much they're telling us they last. Purchasing manager of this company receives a brochure in the mail that advertises a new brand of batteries. This new brand of batteries is cheaper, thus the reason why they probably want to change, than the company currently uses. However, the pricing manager is concerned that the cheaper batteries may have a shorter, another key word, average lifespan than the current brand. Note that the number of hours that the battery lasts is called their battery life. The pricing manager wants to perform a statistical test at the 1% level of significance. Alright, so the only thing we're missing at the moment is the sample mean and sample standard deviation of our new batteries to compare. But that's not what we need to actually continue here to write the null hypothesis. So the null hypothesis, again, is the background condition. So the null hypothesis would be that we would expect, or we would hope, that the cheaper batteries, U, would equal 55 hours. So the hope is that the cheaper batteries are no different. Alright, the HA, my alternative, would be that U is less than 55 hours. Again, we hope this is not the case for the cheaper batteries. Alright, so those are our null and alternative. And the next thing asked is it left-tailed, right-tailed, or two-tailed? Be sure to explain your answer. So up here, you see the less than sign. So that would help us determine that this is going to be a left-tailed test. And the reason why is since we expect our sample to be less than the mean. Okay, so let's collect the data. So the price manager installs 40 randomly selected batteries. Well, that's good news because we meet the criteria that it's greater than 30. They find that the lifespan is 52 hours. Okay, so it is somewhat less. Oh, this should be in yellow. And the standard deviation of 10 hours. So what we got to determine, are these batteries actually significantly lower quality or last significantly less hours if it lasts 3 hours less, if they average 3 hours less on average. Okay, so does the manager sample satisfy the criteria for approximate normality for these distributions? And yes, since our sample size of 40 is greater than 30. Remember, 30 is the magic number that statisticians have agreed on that is required to meet normality if we don't know what it looks like. Alright, so is the sample mean consistent with the alternative hypothesis? Yes, the sample mean is 52, which is less than the 55. Alright, so we can proceed. If this were actually false at this moment, we wouldn't even have to continue. So now we're going to go to the template and fill in the numbers that we need to know. Alright, so let's see here. I'm going to try to split my screen. I don't know how well this is going to work, but we're going to try it. And let's see if I can get the information then. So I'm on the second chart, And let's fill in the numbers from our information. So everything that I have highlighted has to go somewhere, basically. First of all, we have a 1% level of significance. That goes right here. So I do 1%. Hit Tab. The sample size. All right, that sample size is down here. That was 40. My sample mean. The sample is 52 hours, so I type 52. My sample standard deviation is 10 hours. All right. Remember this next one that you fill in, it says the population mean, the mu, is from our null hypothesis. So let's go back to our null. Our null hypothesis stated 55 hours. So go there. And finally, we need to figure out which direction our alternative is saying. Is it -1, 1, or 2? And that's coded as, if you look up here, left, right, or two-tail. And we want the -1 for the left tail. Alright, so now what I'm going to do is create this bigger. I'm going to copy and paste this. So, new. Take that, we're going to paste it into where this one is. Alright, so now let's fill in the answers that we get from this test. So what is the test statistic for the observed sample? So let's go back to our table. Our test statistic is -1.897. So let's do TTS, no capital T here. And we're going to say that equals to -1. What was that number again? 1.897. All right, so we're not quite reaching that threshold of 2. Okay, so the next part. Use the test statistic to find the p-value. So the p-value equals 0.033. All right, so remember this means the probability of obtaining a sample mean of 52 from 40 random batteries or more extreme if the null hypothesis of 55 hours is true. So the probability of getting this sample, if the 55 hours were true, is relatively low. It's only 3%. All right, so how does this p-value compare to the significance level, and should we reject? Well, let's first state this. So since the p-value is greater than 1%, we fail to reject the null hypothesis that the true mean lifespan of the battery is 55 hours. Alright, so that kind of shows that my sample batteries of cheaper batteries could do, because would be okay, because the mean lifespan is not that much lower. So what can we conclude about the alternative hypothesis? The alternative hypothesis is not true. All right, and state the conclusion in the context of the problem. I already did that above. See number 8. Is it possible that the conclusion was incorrect, that the new batteries may indeed have a shorter lifespan of batteries? If this is the case, what type of error was made? Since we failed to reject the null when the alternative was true, we would have made a type 2 error. Alright, so I hope that helps with understanding how to do a hypothesis test for this. If we actually had a 5% significance level, then we would have rejected the null hypothesis, but in this case, we did not have enough evidence to reject the null hypothesis, and therefore, purchasing the cheaper batteries may not cause that much of an impact on the walkie-talkies. Alright, so that's the end of this video.